This is question number 6 of exercise 1.2. Let's see. Let A equals to 1, 2, 3, B equals to 4, 5, 6, 7 and let F equals to 1, 4, 2, 5, 3, 6 be a function from A to B. Show that F is 1, 1. So let's see here. We need to show that the given function is 1, 1. So let's solution here. Function we have 1, 4, 2, 5, 3, 6. Let's see by arrow diagram here. For understanding A and B, two sets and element of in A 1, 2, 3, element in B 4, 5, 6, 7. So according to function, 1 is related to 4, 2 is related to 5, 3 is related to 6, isn't it? But in B, 7 has no pre-image in set A. It is an orphan element, and every element of A has one and only one image in B. So we can say F is 1, 1, not on 2, isn't it? So we can write in such a way, implies 1 equals to 4, 2 equals to 5. If we put, we will get 5 as a function, and if we put 3, then we will get 6. So therefore we can say different elements of domain have different F images in the range. F such that A tends to B is 1, 1. And you can write only here, show this picture as an answer and write every element of set A has one and only one image in set B. There it is F is 1, 1. So we can write in a short such a way, isn't it? Now see next question here. Question number 2. In each of the following cases, state whether the function F is 1, 1 on 2 or bijective. Justify your answer. So let's see first part first. F such that R tends to R. The function we have fx equals to 3 minus 4x, isn't it? So let's see first 1, 1. Let x1, x2 belongs to as a domain R, B any two elements, any two elements. Then fx1 equals to fx2. And what is the function? 3 minus 4x1 and 3 minus 4 3 cancel by 3, and we will get minus 4x1 equals to minus 4x2. 4 to 4 cancel, so we will get finally x1 equals to x2. So therefore f is 1 1, we can say f is 1 1. Now let's check on to let y equals to y belong to codomain R, be any element. Then y equals to fx and y equals to 3 minus 4x. So we will see here 4x equals to 3 minus 5. So x equals to, we have 3 minus 5 upon 4, isn't it? So here we can write for y equals to 2, or we can take any value as a y, as a real number. We have x equals to 3 minus 4 upon 3 minus 2 upon 4, so 1 over 4 belongs to R as a domain, isn't it? So we can take any value for y, we will get the value x belongs to R, because both are real number, domain as well as codomain. So we can say therefore f is onto. At last we can say f is, thus f is 1 1 onto or bijective as well. Isn't it? So second part you can do yourself. If you have got any problem, write me on comment box. So now move to next question. Question number 8. Question number 8 here. Let A and B be sets so that F such that A cross B tends to B cross A. It is a Cartesian product, we can say, such that FAB equals to BA as a order pair is a bijective function. So now for solution, let x1 equals to AB as a order pair and x2 equals to A dash B dash belongs to, both belongs to A cross B as a Cartesian product, isn't it? Now so if we put the value of x1 in F, so we will get here BA according to condition, and if we put x2 here place in F, so we will get A dash B dash we need to put here, so the value we will get A dash B dash as a ordered pair, isn't it? Now we need to put function as equal for 1 1. First we will check here 1 1 function here. So the value of fx1 is BA and fx2 is B dash, A dash. So we can take element as equal if ordered pair are equal. We are familiar in class 9th as well. So we will get B equal B dash and A equal A dash. You can see here. So if therefore function are equal implies element also equal, isn't it? So because we can say x1 equals to AB or x2 equals to A dash B dash or also equal. We can write here, we can write since as a x1 equals to AB equals to A dash B dash equals to x2. That's the reason here. Now for on to, let y बराबर A double dash B double dash belongs to B cross A as a codomain. Isn't it, of F. Also let A double dash B double dash belongs to B cross A, isn't it? Sorry, we can write here also let x equals to AB belongs to A cross B. B its pre-image, we can say. Therefore FA comma B equals to A double dash B double dash, isn't it? So we can write here BA, the value of FA, A double dash B double dash. So the value of B equals to, so the value of B equals to A double dash and the value of A equals to B double dash. So we can say x equals to, therefore x equals to A B equals to B double dash A double dash. Therefore, and we can say implies fx equals to F double dash A double dash equals to A double dash B double dash as a ordered pair equals to y, we can say, isn't it? So corresponding, since corresponding to every ordered pair there exists AB, so implies FA B equals to A double dash B double dash, implies F is onto. Hence we can say F is bijective. Easily we can say F is bijective. So let's see here. For 1 1 we take x equals to AB b equals x1 equals to ab, x2 equals to a dash b dash as a ordered pair and belongs to their Cartesian product a cross b. So f1 equals to fab. If we put the value x1, so we will get ba, and put the value x2, we will get a dash b dash ba. So if we put function as equal, so we get element as equal b dash. So we can say x function as equal, so elements must be equal, we proved above. So x1 equals to ab, because x1 equals to a comma b order pair and a dash b dash order pair it is x2, we proved above. Now on to let y belongs to a double dash b double dash as a order pair belongs to Cartesian product ba as a codomain, and also let a b belongs to a b its pre-image, we can say. So we put a b equals to b, so we will get a dash b dash since, and ba the value of fa ba, so b equals to a double dash, a equals to a b double dash, x equals to ab. So we got here ab equals to ba a dash. It is a implies, we can say, this condition equals to y. So corresponding to every ordered pair a double dash b double dash, there exists ab such that ab a double dash b double dash. So we can say f is onto, hence proved. Now move to next question here. Let's see question number 9 here. Let's f such that n tends to n be defined by fn n plus 1 over 2 if n is a odd number and n by 2 if n is a even number. For all n belongs to natural number, state whether the function is bijective. Justify your answer. Now let's see. First we will check it is 1 1 or not. Let n1 equals to 1 and n2 equals to 2 belongs to n. Be two natural number, we can say. So if we take here fn1, so we put 1, so we will take the value n by 2. F n is odd, so we will get 2 over 2 equals to 1. If we take n2, we need to put the value here 2, so we will put 2 upon 2 because 2 is a even number, we can say it is even number. So 2 over 2 we will get 1, isn't it? So therefore fn1 equals to fn2 for n1 does not equals to n2, isn't it? Because the value is 1, both condition, but elements are not equal, you see here. So in this case we can say f is not 1 1. So if f is not 1 1, so we can say hence f is not bijective. If a function is bijective, it must be 1 1 on 2. So we can check here f is not 1 1. So we don't need to go on to we can see f is not 1 1 here, so we can say hence f is not bijective. Now move to next question. Question number 10 here. Let a equals to r except 3 and b equals to r except 1. It means that a is a set of real number but not in that set is 3, and same as b is a set of real number except 1. Consider the function f such that a as a domain and b as a codomain by fx x minus 2 x minus 3 is f is 1 1, and want to justify your answer. First we will check as 1 1 or not. So let x1 comma x2 belongs to codomain, then fx1 equals to fx2 implies the value of fx1 such that and the value of fx2 if we cross multiply, so we will get x1 minus 2 x2 minus 3 and equals to x2 minus 2 x1 minus 3. We multiply here x1 x2 minus 3 x1 minus 2 x2 plus 6, and then x1 x2 minus 3 x2 minus 2 x1 plus 6. 6 to 6 cancel because they both have got same sign here, and we put minus a shifting like variables same side and unlike variables other side in x1 and x2. So we will get minus x1 after solving, and here minus x2, minus 2 minus cancel. So finally we will get x1 equals to x2. So we can say therefore f is 1 1. Now second we will check on to here. Let y belongs to codomain r minus 1 be any element so we can write fx equals to y, and the value of fx x minus 2 over x minus 3, and we put 1 here below the y, so we will do cross multiply here. So what will we get? xy minus 3y x minus 2. So after shifting we will get 3y minus 2. So we take out x as a common, y minus 1, and we will get 3y minus 2. So x equals to, we will get 3y minus 2 over y minus 1, isn't it? So now you can see here for y equals to 2 belongs to r except 1. We cannot take the value y here 1 except 1. We can take all value of y. We have the value of x is 3, 2 minus 2 over 2 minus 1. So we will get the value of x here. 6 minus 2 over 1 equals to 4, and 4 belongs to its domain. Isn't it the value of x except 3 all real number? Isn't it? So we can say, so f is onto as well. So it means r minus 3 not 3 in real number. Same as r minus 1 not 1 in real number. Isn't it? If you see in the function, if you put 3 place of x, so the function is not defined because we will get 0 as a denominator. So function is not defined. Here if you put 1, so we will get denominator as a 0. So that in this condition function is not defined. It is the reason about that. So now we have got 2 question remaining, question 11 and 12. This is question number 11 here. Let f such that r tends to r be defined as fx equals to x raised to power 4. Choose the correct answer here. First we will check. We have 4 option here. First is f is 1 1 onto, second is f is many 1 onto, third is f is 1 1 but not onto. So D is f is neither 1 1 nor onto. Let's first check it is 1 1 or not. Let x1 x2 belongs to R. Be any 2 element, then fx1 equals to fx2. So the value we put here, and the finally x1 equals to plus minus x2. So x1 have 2 value, negative and positive. You can see here. How? Let's understand with an example. If we put x1 बराबर 1 and x2 बराबर minus 1. So if we put 1 here, so we will get 1 raised to power 4 equals to 1, and if we put minus 1 here, so we will get minus 1 raised to power 4. So we will get 1 here. So function are equal, the value of function are equal, but elements does not equal. So we can say f is not 1 1. Isn't it? Now see onto. So onto we can write here. Let y equals to fx. We will take directly, and the value of fx is x raised to power 4. So we will get x equals to y raised to power 4. So in this condition we will get all positive value of x. If we understand by ray diagram here, x square is 4 is a function. So if we put 1 here, so we will get 1. If we put minus 1, so we will get 1. And in this diagram, as a domain, as a codomain, we have -1, -2, so there's a no pre-image, no pre-image, we can say that here we put all negative value, we get positive value here, isn't it? But what about the negative value of this set, codomain set, because it is a real number and it is also a real number. So what about the negative number? They are orphan element here, we can say. So the function is not onto in this condition. So we can write in mathematical way also x raised to power 4 greater than or equal 0 for all x belongs to natural number. Therefore range of fx equals to always 0 to infinite, does not equals to r. So we can say f such that r tends to r is not onto. Clear? So our D option is correct here, isn't it? Now we have 12 questions remaining here, so you can do 12 questions yourself. Try and write me on comment box if you have got any problem. Thanks for watching this video.